are here to talk about a very important topic that JAM will always bring in their questions. For the 40 questions you'll be answering in JAM. Quickly, without even wasting much of your time, I'll be teaching chemistry this afternoon. And one of the very important topics I'll be teaching is electrolysis. Electrolysis is said to be one of the very topics that students have deficiency in when they have to do with questions ranging from JAM and WAEC. Electrolysis has a part of it that entails calculations. And so many students just prepare their mind because they just want to get an idea about the definitions, the laws. The calculation is very, very important. And they have issues with that because they have not seen somebody that will bring that calculation down to a better steps that they can understand it and be able to put it well in exam terms. Electrolysis is very easy. Get yourself ready as we take this lecture for the next few minutes to ensure we get the best. Are you ready? Yes. Quickly, let's go. Right. Electrolysis. Electrolysis can be defined as a chemical decomposition of a substance called electrolyte that allows electric currents to pass through them, either in molten or in solution. Now, we're talking about electrolysis. We said it's a chemical decomposition. Now, look up here, please. Quickly, one else. Look up. When we're talking about chemical decomposition, it simply means a substance is being decomposed. And we said electrolysis is defined as a chemical decomposition of a substance called electrolyte. There's a substance we call electrolyte. Electrolysis was discovered by Michael Faraday. It was his own ball game. It was something he did in the lexicon of time that we can never forget him about. Without Michael Faraday evolving electrolysis, there will be nothing like electron passing through water. It is electrolysis processes that is used in getting the NEPA light we see. It's electrolysis processes that is used in getting currents that we make use of in our daily activities. So electrolysis is said to be the chemical decomposition of a substance called electrolyte. Now look up please. What is an electrolyte? That's what comes to your mind. Every terminologies in science demand explanation. Electrolyte. Now look up. Electrolyte can be said to be a substance that can allow electric currents to pass through them and leave them. Examples of electrolytes are salt. Salt is an electrolyte. Acid is an electrolyte. Base is an electrolyte. Those compounds that can be decomposed, either in their molten state, current will pass through them, or in its solution state, current will pass through them. And that's why you see we have currents evolved out from water through a process we call HEP. HEP is known as hydroelectric power. That's why we get the light we make use of. And you know something about them, whenever they want to get this light, they make sure they use a water that contains salt. Like I said, salt is an electrolyte. They don't use an ordinary water. The water that contains maximum amount of salt. That electrolyte is being discovered and is used as current. This was what Michael Faraday sat down and evolved out electrolysis. So electrolysis is something you must understand that goes on the same similitude with physics and chemistry. So electrolysis has to do with electron allowing current passing through water. Naturally, current cannot pass through water. Current can pass through conductors, wires. But now Michael Faraday came out with an idea that allows current pass through water, and he called that terminology electrolysis. Is that very fine? Now look up. Michael Faraday is very renowned. He's a scientist that has an edge in the history of science. He came out with a law, and he named that law Faraday Laws of Electrolysis. Now look up. His discoveries were very unique. His discovery gave out the first law called Faraday's first law of electrolysis. He did a further discovery that brought out the other law called Faraday's second law of electrolysis. Quickly, as scientists don't communicate with just verbal words. They use definition to express what is in their hearts. they use calculations, they use theorems, they use formulas, they use diagram. Those are the way they communicate. And that's why Faraday gave us a platform to tell us that electrolysis can be defined, electrolysis can be calculated, electrolysis has a diagram to buttress it, electrolysis has a graph to buttress it. Quickly before I proceed, I want us to get familiar with the first law of electrolysis. Michael Faraday was very sensitive and he gave us that. Right. Faraday's first law of electrolysis. Faraday's first law of electrolysis states that mass of substance liberated during electrolysis is directly proportional to the quantity of electric current that passes through the electrolyte. Now look up here, look at the board quickly. Every theorem demands a mathematical expression, and that's why you must understand this. From the what we said that the mass of substance, the M stands for mass of substance liberated during electrolysis, is directly proportional, that's the proportional sign, is directly proportional to the quantity of electric current. Quantity is noted as Q, that passes through the electrolyte. From the philosophy of calculation or variation, we're taught that when we have mass and we have this, whenever we are removing an equal to, we are going to have a K. Yes or yes?
Yes.
And that K stands for a constant with a quantity. But now look up here, let me amaze you. Every topic has a uniqueness. In electrolysis, we don't use this K. In mathematics, the K is visible. But in electrolysis, we use mass of substance is equals to ZQ. That's the uniqueness of electrolysis. So on the strength of this, we have to make Z the subject of the formula. Divide both side by Q. We have divide both side by Q. Our Q is out. We have Z is equals to M over Q. Now mind you, quantity of electric charge is measured in coulombs. So now look up here. Quantity can be said to be IT. For us to get the quantity, we must know the current times the time. The current times the time. Who can help me out? What's the SI unit for current? What's the unit for current? Again? What's the SI unit for time? Again? What's the SI unit for quantity itself? Again? Yes, it is known as coulombs. The man that founded Coulomb's law of electric charges in physics was the man that founded this unit as coulombs. Don't let us digress, let's focus on electrolysis. So we have Q equals to IT. On the strength of this, on the board here, we can see that Z can be said to be M over IT because my Q is equals to IT. Is that very fine? Now what's my M? My M stands for mass. My I stands for current in ampere. My T stands for time. So whenever you are given a question in electrolysis, you can be able to address them using this formula. This Z is standing for a constant. What do I call it? Because a JAM student, you must be very familiar with laws. There are so many laws that the exam can demand from you. Each topic has a law that governs them. On electrolysis, we have two laws. The first one has been stated, we have the second one. They were stated by Michael Faraday. Right, subheading, terminologies used in electrolysis. Number one, electrolytes. Number two, non-electrolytes. Number three, electrode. Number four, conductor. Number next, insulator. Number next, ions. Just to differentiate that, we have two types of ions. We have the cations and the anions. The cations, are they called positively charged or negative charged?
Positively charged.
They are called positively charged ions. Why the anions are called what?
Negatively charged ions.
Good. Now this is to clear you. In an electrochemical series, let me give you an example of what we call an electrochemical series. Watch on the board quickly. Electrochemical series is something that looks like this. There's a diagram like this. You always see in your textbooks, if you have been familiar. You see this one will come like this, this will come like this will be positive, this will be negative, and there'll be an arrow here. There'll be an arrow here. There'll be a cell. A cell. This is called the positively end of the cell. The longer one is positive, while the smaller one is negative. Now you will see that there is electrons flowing into this place in an electrochemical series. An electrochemical series is a series that contains ions, two different ions, positive and negative, and they put them into a jar. Water is entailed. They mix an electrolyte, either salt, acid or base, into it, just to ensure that current flows, and they can use this charged current to detect this. So in an electrochemical series, like I was saying, an electrochemical series and a particular anions is an electrochemical series, it will move to the negative side. All the positive charge will become negative, and all the negative charge will become positive. Quickly, before we go into that, you must know all the anions and you must know the cations. They are short forms. As science students, you only learn through acronyms. We have all the anions enloaded into an acronym. I'll teach you here. We have all the cations enloaded into an acronyms. These acronyms helps you to remember them very well with their ion. On the cation strengths, we have all the positively charged ion. I derive an acronym that is known as popular scientists can make a zoo in thin, low, humid condition, moderately satisfying goods. Those are the ways I can know my cations. And my anions, I derive an acronym that says flora so no clean broom in hurry. Or you use food scientists now claim before inspecting oil. Is that very clear?
Yes, sir.
So these are acronyms that can be used to get the anions and to know the cations.